Hello everyone, myself Hans. Today we are going to solve the problem of UPSC Maths of Non Paper 1 question from topic differentiation under the sign of integration and integral as a parameter of system. Here in the question given by so that integral limit is 0 to pi by 2 log 1 plus of cos alpha into cos x upon cos x is equal to 1 by 2 into pi square by 4 minus of alpha square. Let's solve the problem. Given integral is given by I is equal to, this is limit 0 to pi by 2 and log of 1 plus of cos alpha into cos x upon cos x, and we have to prove the right hand side. Here the parameter is parameter is alpha, and we have to differentiate the and also write this equation 1 and differentiating equation 1 with respect to parameter alpha, differentiating equation 1 with respect to parameter alpha, and differentiating, that is di upon d alpha is equal to 0 to limit is pi by 2, and here log 1 plus of cos alpha and cos x, differentiating with respect to alpha, this is given by log x, that is 1 upon of cos x is already present, and this is given by 1 plus of cos alpha into cos x, and further we have to differentiate again cos alpha into cos x with respect to alpha, this is given by minus of sin alpha into cos x, and this is dx. Here is dx is also present, dx, and this is also here a dx. Further we have to solve, taking from here we have to take once again from here cos x to cos x is cancelled out, and the remaining is minus of sin alpha is taken into outside, and integral limit is 0 to pi by 2, and here is remaining, this is dx upon 1 plus of cos alpha into cos x, and further we have to know that this is cos x is given by, cos x is also given by, that is 1 minus of tan square x by 2 upon 1 plus of tan square x by 2. Further we have to put the following formula here, that is di upon d alpha is equal to minus of sin alpha, and integral limit is 0 to pi by 2, and here dx upon 1 plus of cos alpha, and here we have to put the formula of cos x, that is 1 minus of tan square x by 2 upon 1 plus of tan square x by 2, and further we have to take LCM in the denominator, that is minus of sin alpha, and integral limit is 0 to pi by 2, and here is dx upon, taking LCM here, 1 plus of tan square x by 2 is multiplied with 1, that is 1 plus of tan square x by 2, and here is plus of cos alpha, and in the 1 minus of tan square x by 2, and upon 1 plus of tan square x is sec square x, and sec square is taken into numerator, this is given by here sec square x by 2, and further we have to solve, that is di upon d alpha is equal to minus of sin alpha and minus of sin alpha, and integral limit is 0 to pi by 2, and this is sec square x by 2 dx upon, and from here we have to take, once again we have to multiply, that is 1 plus of tan square x by 2, and we have to multiply the cos alpha with this bracket, that is plus of cos alpha and minus of cos alpha into tan square x by 2, and further we have to take common from denominator, that is tan square x by 2 and minus of cos alpha tan square x by 2. Hence from here we have to take common tan square x by 2, that is minus of sin alpha, integral limit is 0 to pi by 2, and here is sec square x by 2 dx upon, and from here first we have to write, this is 1 plus of cos x is here, 1 plus of cos x, 1 plus of cos x, and we have to take common tan square x by 2 from this part, this is plus of tan square x by 2 is taking common, and the remaining is here 1 minus of cos alpha, 1 minus of cos alpha, and further we have to also write, that is 1 minus, and taking common from denominator, that is 1 minus of cos alpha, that is di upon d alpha, di upon d alpha is equal to minus of sin alpha, minus of sin alpha, and we have to take a common from denominator, and here is integral limit is 0 to pi by 2, and sec square x by 2 dx, and from denominator we have to take common 1 minus of cos alpha, taking common, and the remaining is here 1 plus of cos x upon 1 plus of 1 minus of cos alpha, 1 minus of cos alpha, and plus of tan square x by 2, and this is, further we have to take, we can also write, that is minus of sin alpha, and we have to also in the denominator 1 minus of cos alpha is taken to outside, that is minus of sin alpha upon 1 minus of cos alpha, and the integral limit is 0 to pi by 2, integral limit is 0 to pi by 2, and the remaining is here sec square x by 2 dx upon, here is 1 plus of cos x, 1 plus of cos x upon, once again take common tan square x, and 1 minus of cos alpha, 1 minus of cos alpha, and plus of tan square x by 2, and further we have to solve, once again further we have to solve, that is di upon d alpha, and minus of sin alpha is written as minus is already present, that is 2 sin alpha by 2 into cos alpha by 2 upon, here is 1 minus of cos alpha, that is cos alpha is written as 1 minus of 2 sin square alpha by 2, and further we have to take a integral limit, this is 0 to pi by 2, and sec square x by 2 into dx upon, we can also write here 1 plus of cos x, that is 1 plus of, in place of cos x we use the formula, that is 2 cos square x by 2 minus of 1 upon, here is 1 minus of cos alpha, that is 1 minus of, in place of cos alpha we have to put 1 minus of 2 sin square alpha by 2, and here is plus of tan square x by 2, this is tan square x by 2, and further from here cos alpha, one second, when taking 1 plus of tan square x and cos alpha, here is 1 plus of cos alpha, here is not a x, here is cos alpha. Cos alpha, we have to some correct the terms, here is cos alpha, we have to take common, this is 1 plus of cos alpha, this is also alpha, and here is also not a x, this is alpha, and further from here we can also write here is alpha by 2, and further from here, that is minus 1 to plus 1 is cancel out, and further we can also write the terms, that is di upon d alpha is equal to, here is minus of 2 sin alpha by 2 into cos alpha by 2 upon, here we have to minus is multiplying with this bracket, that is 1 minus of 1 plus of 2 sin square alpha by 2, and from here minus 1 to plus 1 is cancel out, and the integral limit is 0 to pi by 2, and here is sec square x by 2 and dx upon, here is 2 cos square alpha by 2 upon, here we have to multiply minus with this bracket, that is 1 minus of 1 plus of 2 sin square alpha by 2 and plus of tan square x by 2, and from here this is minus to minus is cancel out, and the remaining is from here, that is di upon d alpha, and this is equal to minus of 2 sin alpha by 2 into cos alpha by 2 upon, here is 2 sin square alpha by 2, and integral limit is 0 to pi by 2, and this is given by sec square x by 2 dx. One second, here is also when taking LCM tan square x, sec square x by 2, and from here is 2 cos square alpha by 2 upon, here is 2 sin square alpha by 2 and plus of tan square x by 2, and from here, that is 2 is cancel out, and sin square alpha to sin alpha by 2 is cancel out, and the remaining is here sin alpha by 2 is remaining here, and further from here 2 to 2 is cancel out, and we can also write, that is here is remaining, that is minus of cos alpha, one second, 2 sin alpha by 2, 1 minus of 2 sin square by 2, and sin square alpha by 2 is cancel out, and 2 to 2 is cancel out, that is minus of cos alpha by 2 upon sin alpha by 2, that is minus of cot alpha by 2, and the integral limit is 0 to pi by 2, and here in the numerator, that is sec square x by 2 into dx upon, here is cos square alpha by 2 upon sin square alpha by 2, this is given by cot square alpha by 2 and plus of tan square x by 2. Further from here we have to solve it. Let let 10 is 10 x by 2 is equal to t, and we have to differentiating here, that is 10x by 2 is given by sec square x by 2, and again x by 2 multiply with differentiate x by 2 with respect to x, that is 1 by 2, this is given by 1 by 2, and this is dx is equal to dt. And we have to also change the limit here. When we have to put x is equal to 0, we get, when x is equal to 0, we get t is equal to 0, and we get, when we put, when x is equal to pi by 2, then t is equal to, when we have to put x is equal to pi by 2 here, that is, this is given by t is equal to, here is pi by 4, and pi by 4, the 1045, the value of 1045 is what? This is equal to t is equal to 1. So we have to first change the limit here, that is di upon d alpha is equal to, here is minus of cot alpha by 2, and integral limit is 0 to 1. New limit is changing after the taking 10x by 2 is equal to t, and from here we can also put the value of dx here, and we can also put once again sec square x by 2 dx. Once again, from here we can also write, that is sec square x by 2 dx in place of 2 dt, and we can write in place of sec square x by 2 dx in place of 2 dt. This is 2 dt upon, here is cot square alpha by 2, this is cot square alpha by 2, and plus of t square. We have to let here 10x by 2 is t. Further we have to solve. Further we have to solve using the formula. We know that is in dx upon a square plus of x square is given by 1 by a and tan inverse of x by a. Using the following formula here, that is di upon d alpha, and here minus of 2 is taken into outside, that is minus of 2 cot alpha by 2, and here we have to put the following using the following formula, that is here let a is cot square x by 2, this is a square plus t square. Then we have to write the formula, that is once again, this is 1 by of a, that is cot alpha by 2, and tan inverse of x by a. Here t is x and a is cot alpha by 2, and the limit is here 0 to 1. Further we have to put the limit. First we have to cancel out the terms, that is cot alpha by 2 into cot alpha by 2, and the remaining is here once again di upon d alpha is equal to, here is minus of 2, and we have to put in place of t is equal to 1, and this is 1 upon cot alpha by 2. 1 upon cot alpha by 2 is taken to denominator, that is tan alpha by 2, and this is tan inverse, and tan alpha by 2 is removing, we get alpha by 2 from here, and from here alpha by 2, once again tan alpha by 2 is cancelled. From here we can also cancel out, this is minus of alpha on di is equal to, here is minus of alpha and d alpha. Further we have to solve on integrating both the sides, that is di on integration, this is I, and here is minus of alpha square upon 2 plus c, and we have to find the value of I from equation 1. Put alpha is equal to pi by 2. Alpha is equal to pi by 2, when we have to put in place of alpha pi by 2, and the value of cos 90 is 0. So from here we get I is equal to 0. I is equal to 0, and further we have to put here, that is I is equal to 0, and in place of we have to put alpha is equal to pi by 2. Here we have to put pi by 2. This is minus is already present here, and alpha, this is alpha square we can also put, that is pi square by 4, and pi square by 4 upon 2, this is pi square upon 8 plus of c, and from here we get the value of c, that is c is equal to pi square upon 8, and again we have to put the value of c here. We get the required solution, that is I is equal to minus of alpha square upon 2 and plus of pi square upon 8, and we can also write the terms, that is I is equal to pi square upon 8 minus of alpha square upon 2, and from here this is I, from here we have to take common 1 by 2, 1 by 2 is taking common, then pi square upon 4 and minus of alpha square. This is the required solution of the right hand side. We so that this is the equal to right hand side. We have to prove 1 by 2 pi square upon 4 minus of alpha square. This is the required solution of the given problem. If any doubt, kindly comment in comment section. Thank you class, and thank you for watching.